Alright, in this video I will tell you why is cos x the derivative of sin x. And the method which I'm going to be using can also be used by high school students in their exams for derivation. So yeah, let's get down to business. Alright, we have to find the derivative of sin x. Now if f of x equals sin x, we can write f of x plus h equals sin of x plus h. Make sense? So now I'm going to be making use of the first principles, which says f inverse x equals limit h tends to 0 function of x plus h minus function of x whole divided by h. Let's put this to the side. Now it's time for substitution. F prime x equals limit h approaches 0. F of x plus h is sin of x plus h. So sin of x plus h minus f of x is sin x. So sin x whole upon h. Now we need the help of a trigonometric identity which says sin c minus sin d equals 2 cos c plus d over 2 times sin c minus d over 2. Let's put this in a box. And now we're going to write this equation in terms of this identity right here. So let x plus h equals c, x plus h equals c, and x equals d. X equals d. From here we can write f prime of x equals limit h tends to 0 and then sin c minus sin d whole upon h. If we solve this equation, we get f prime x equals limit h tends to 0 2 cos c plus d over 2 times sin c minus d over 2 whole upon h. Now we have to substitute the values of c and d in this equation. So f prime x equals limit h tends to 0 2 cos c was x plus h and d was x divided by 2 times sin c was x plus h and d was x over 2 whole upon h. On further simplification of this, we get limit 2 cos x plus h over 2 times sin h upon 2 over h. Oh, here h tends to 0. Now what we do is we take this 2 in the denominator and we separate the limits. So limit h tends to 0 cos x plus h over 2 times limit h tends to 0 sin h over 2 upon h over 2. This 2 is the 2 over here. There's an identity in derivatives which says limit x tends to 0 Sin x over x equals 1. So this is the exact thing which we are going to use in this part of the equation. So we get limit h tends to 0 cos x plus h over 2 times limit x tends to 0. We substitute the value of h over 2 as x. So sin x over x. So this whole thing becomes 1. Limit h tends to 0 cos x plus h over 2 times 1. Now we're going to solve for limits and get the final answer, which gives us cos x limit h tends to 0. So 0 over 2. 0 over anything is 0. So the final answer is cos x. Hence we have proved why cos x is the derivative of sin x. Thanks for watching Integrated Pi. I'm Kaustubh Dev.